Hydrate practice. Question 1. Copper 2 chloride, when heated to 100 degrees Celsius, is dehydrated, meaning the water has been removed. If 0.235 grams of copper 2 chloride with some number of water molecules gives 0.185 grams of copper 2 chloride anhydrous on heating, what is the value of X? So what are we trying to do here? We have two numbers that are given to us. One is the value of the mass of the hydrate, one is the value of the mass of the anhydrate. So one with water, one without water. So we want to write those down. So hydrated salt is 0.235 grams and anhydrous salt is 0.185 grams. Now we want to take the difference between the two of these. We're going to subtract the two, and when we do that, we get 0.05 grams of H2O. Once I've found the difference between the hydrated salt and the anhydrous salt, I can go to my next step. And that next step is converting my mass of water into moles. So 0.05 grams of H2O. I know that there is 18 grams, my gram formula mass of water, in 1 mole of water. So 1 mole of water. And of course here I'm going to cancel my units, so grams cancels grams. And when I do this, I find that I have 0.0027 moles of water. And I'm not going to round here. I'm going to definitely take this out a bunch of decimal places. The next thing I want to do is take the mass of my anhydrous salt, so only the ionic compound, no water molecules involved, and convert that into moles. So 0.185 grams of CuCl2. Again, we're going to convert that into moles. So 1 mole of CuCl2. The gram formula mass of that is around 134.45 grams of CuCl2. Again, I'm going to cancel my units, so grams of CuCl2 cancels grams of Cl2. So if I multiply 0.185 times 1 divided by 134.45, I find that I have about 0.0014 moles of CuCl2. So just a little review of what we've done so far. We've taken our mass of our hydrated salt and we subtracted the mass of our anhydrous salt and found our mass of water. We converted our mass of water into moles, and we converted the mass of our ionic salt also into moles. Now what I'm going to do is take the moles of water, moles of H2O, and I'm going to divide that by moles of copper 2 chloride. So if I substitute my values in, I get 0.0027 divided by 0.0014, and I find that that number is 2. So this 2 right here represents the red X that we see in this formula right here. So CuCl2 dot 2H2O, which means in a hydrated sample, for every 1 mole of CuCl2, there's going to be 2 moles of water.